Thank you, Madhukar. Next, I would like to introduce Chienchung Chang, who did his undergrad from Taiwan, and then he did his master's and PhD from UC San Diego here. And since then, he's been working in Qualcomm, and he's been with Qualcomm for 30 years. Since he's done very well, he's grown to be a VP of engineering at Qualcomm Technologies, where he leads the multimedia R&D and standards group, with major focus in forward-looking research in the field of video, speech, imaging, computer vision, AI, and XR technologies. His team has been heavily engaged with standards in speech, video, imaging, computer vision as well. He will give us overview on the boundless XR. Chienchung, please take it.
Thank you, Naresh. Can you hear me well?
Yes.
Okay. Let me share my screen a little bit. First, I would like to give you a small video regarding the concept of the boundless XR over here. Okay, so this the video I would like to share with you so that you have some background. What does boundless XR extended reality I'm talking about here? I don't have too many slides. I just have I just want to show you one or two slides and stop there, and then I will get into a little bit more detail regarding the relevant technology we are developing in Qualcomm. So basically, in this forum, we are talking about the centerpiece is the 5G network, which is going to provide the superhighway with high bandwidth and low latency air interface. And there are a lot of applications and very interesting stuff is going to be enabled by the 5G network in the near future. And definitely including the new mobile handset, but the XR is going to be one of the application I would say will take full advantages of the 5G network. So here is the major idea we have within Qualcomm. Basically, in the 5G age, whenever we are trying to enable the XR applications, there are many components over there. I think, personally, I think to enable the XR devices itself, basically you put the screen so close to your eyes. Either you are wearing the AR glasses or VR headset. Those screens are so close to your eyes, and then you have a human visual system has a very high requirement regarding the quality over there. So the problem itself is even harder than the smartphone, and the bar is even higher. Okay, so I'm not sure any one of you have Facebook's Oculus's Quest 2 VR headset. They have a 2K by 2K screen, but whenever you put a screen so close to your eyes, user experience seems to me those screens, the quality, still need to be improved, right? So that's my personal experience with Quest 2 from the Oculus. And here I'm talking about the XR headset. Either, especially for the AR headset, there are a lot of challenges over there. I'll get into a little bit more detail regarding what kind of technology I'm talking about here we are developing. And you can take a look here. In this slide, basically, I just try to show you whenever we are moving our head, the contents basically is located in edge cloud or even further away from the real cloud. Okay, so the edge cloud could be very close to the base station, and still, if you have your motion on the XR side, on the XR headset side, those information has to pass through the edge cloud and then render back through the network, 5G network, back to your headset. So the latency over there is really a big challenge. That's probably is the biggest challenges today in the XR application. And not to mention on the headset itself. Can you see my mouse pointer here? Maybe I can get the laser pointer.
Yes, we can see.
Okay. And on the XR headset side, on the devices side, we are developing quite a bit of the technology in my team. Try to overcome the challenges to enable the XR in the 5G. Okay, first we are working on some kind of hand gesture, hand tracking, and detection technology, so that you can have a hands-free without the remote control. You can use your hand to control your AR glasses or VR glasses. Okay, so this is and hand detection and tracking and also the recognition is a very hard problem, even harder than the face recognition itself. Okay, and then whenever you are wearing the glasses, there's another fundamental technology. It's called 3D reconstruction. You have to be able to construct it the three-dimensional surface surrounding you, in real time. And that one is a very challenging problem as well, and based on the 2D camera today, but eventually maybe the sensor need to be involved as well. We are looking into a 3D camera as well. And the other piece of the fundamental technology is 6 degrees of freedom head tracking. Definitely, that one is a very fundamental technology we already have in Qualcomm. We have been doing that for many years, and we are one of the first company to provide a solution in the marketplace. But I think 6 degrees of freedom head tracking technology, the accuracy, the endpoint errors still need to be significantly improved, especially for the AR glasses. Whenever you are wearing the AR glasses, you can see a real object. And if your head tracking is not accurate, you won't be able to put the virtual object on the precisely on the surface of any object in the real object over there. So there's this is a very big challenge for the six stop. And the other thing is really any kind of application you are using, because your camera is hooked up on your glasses, right? And your head could be moving, so the glasses could be moving as well. So if your six-stop head tracking technology is not accurate enough, it's going to have a very big impact of your hand tracking, of your 3D reconstruction, or even image segmentation, etc. So in order to create the real time and also the low power consumption and also the size, try to miniaturize the glasses size and also the weight, and also different kind of thermal threshold whenever you are wearing the glasses. Those are all the real challenges ahead of us. So we are looking into the distributed computing system. I think there's a gentleman before me. He was talking about the split processing for the video, but I'm talking about in general. For any kind of processing you are going to do in the glasses. If the glasses is just like your regular glasses today, is so light, not too much computation can be done in the glasses. So in Qualcomm, we are looking into the distributed processing between the glasses, the mobile phone, and also the edge cloud, and also the real cloud, probably pretty far away from the base station. And also within the devices itself, we are looking into the distributed power consumption and computing processing between the sensor and application processor, etc. Okay, so those are all the different kind of architecture issue. Some of them my team is looking into, and the video I just showed you, those are the video taken in the XR R&D lab in my group, and also the other thing is really the edge cloud. Edge cloud today, the definition of the edge cloud is still pretty murky today, because of edge cloud. Who is going to be the owner of the edge cloud? Is that going to be the joint owner of the mobile operator like Verizon, AT&T, and some real content provider like Microsoft or Facebook or Amazon, etc. Those are still to be seen. And excuse me, I hear some echo over here. Okay, and also there are some computer vision technology we are developing in-house, which is going to be so much important for the glasses you are wearing. For instance, we are looking into the image segmentation so that 3D reconstruction and head tracking and hand tracking will be more accurate, and also machine learning algorithm in general, and depth from stereo, and also motion optical flow. And definitely the architecture for the split rendering between the cloud and the devices is also such an active research in my group. And very last, what I would like to mention a little bit is really.
Can we? I think we are running short of time. Can we summarize quickly? Sorry.
Okay.
Apologize.
Okay. And I think I just want to have a very last point over here is really today. If you take a look at Apple's Wearable, they have a watch, right? And watch today there's a very ultra thin modem, very ultra low power modem in the watch today. So I'm pretty sure in the AR glasses or VR glasses in the future, there's going to be a very slim modem associated with the glass as well. Okay, so I think it's very fun to see the boundless XR experience from here. Yeah, that's my conclusion. Yeah.
Thank you, CC. Just to give you a little, I think this was pretty impressive. I've seen the lab myself and experienced it firsthand. And the lab is pretty impressive with all the infrastructure that you have put in. And I can tell you from my personal experience setting up VR delivery using edge compute, we were trying it with Wi-Fi. It was and supporting 10 simultaneous users. It was pretty tough. So, anyways, with that, thanks, CC.